Welcome to Pomodoro Joe for Thursday, May 25th, 2023. I'm actually a day late on this one, but we'll jump in. Today we're doing LeetCode problem 837, new 21 game. This is a medium problem. Alice plays the following game, loosely based on the card game 21. Alice starts with 0 points and draws numbers while she has less than k points. During each draw, she gains an integer number of points randomly from the range 1 to max points inclusive, where max points is an integer. Each draw is independent and the outcomes have equal probabilities. Alice stops drawing numbers when she gets k or more points. Return the probability that Alice has n or fewer points. So answers within 10 to the negative fifth of the actual answer are considered accepted. All right. Oh man. This is a really hard problem. This is like the hardest medium I've ever seen. All right, we got some constraints. Okay, so with that, we will put 25 minutes on the Pomodoro timer and we will get started. So let's see, we'll need some result. We'll set it to 0 to start with and we'll return our result at the end. Now, how do we tackle this one? I think we're going to need a little bit of magical thinking for this one to work, but let's see what we can do. Let's start with what we know. So anytime she draws a card, she has a 1 in max points chance of getting any particular card. So you can think of this as if you're rolling a 6-sided die, your chance of getting any particular number is 1 out of 6 because you have 1 face up out of the 6 faces. So your chances of rolling a 1 is 1 in 6. Your chance of rolling a 2 is 1 in 6. Your chance of rolling a 6 is 1 in 6, so on and so forth. Okay, so our chance of drawing any particular card, there's between 1 and max points different values. So we get one of those values, so we get 1 out of the 1 in max points values. So that's 1 over max points. So let's see, I'm going to I call this per draw probability. That's just 1 divided by max points. Now this is a floating point divide, not an integer divide. Actually, I'll make this 1.0 just to be clear that this is floating point. Okay, so we've got our probability. Now on our first draw, our probability of getting 1 through max points, each one of those will have a probability of 1 over max points. Then on our second draw, that's where it gets complicated. We no longer have any probability of getting 1 because we have to have at least 2 points. But our probability of having 2 points goes from being this 1 over max points to being 1 over max points times 1 over max points because we had to draw 1 on the first draw and a 1 on the second draw. So the probability of those two things happening is just the probability of the first times the probability of the second. This is going to get really complicated the more we draw. So let's take a different approach. Let's see, what do we know here? We know we want to return the number of points that she can end up with that are below some value n. Or is it inclusive? Let's see, n or fewer, so it's inclusive. Okay, so we do know something. This is where our magical thinking comes in. So for every point value in the range from 0 to n plus 1, because we're including n and range is exclusive. So for every point value in this range from n to n plus 1, let's just pretend we have some function that gives us the probability that we'll end up with those points. So we'll just increase our result by that probability. So let's have some magical function here. So we have this probability of ending with points, p points, and we'll just add that to our result and then we'll return our result and we're all good, we're done. Okay, so now we actually have to implement this function. This is the hard part. All right, so let's come up here and we'll create a new function. So now this is our function to tell us if we end on, or the probability of ending on any particular set of points, p. All right, so what can we say here? Well, we have a base case of, well, 0 points. What's our chance that we'll end up with 0 points? I guess it depends. Maybe k is 0. we might need to actually add some special casing here. Yeah, I think we need to add a special case here. So if our k is 0, that means we don't ever draw anything. Then we'll end up with 100% less than n as long as n is greater than k. Let's see what our constraints say. Yeah, k is always less than or equal to n. Okay. So let's add a special case up here. If k is equal to 0, we'll return 1 because we can't draw anything. It has to be less than or equal to n, so that's just some special case. And back to this one. Probability of ending with points p, well, it's not going to be 0. Well, if we have 0 points, we can't end with 0 points unless k is 0. Otherwise, we have to draw at least one card. All right, so we can do something where if p is, well, we already know it's greater than 0. Oh, actually, we don't know it's greater than 0. We could be passing in a 0 here. P equals 0. There's a 0% chance we're going to end up on that because we have to draw at least once. If p is equal to, well, 1, well, there's going to be a 1 in max points chance. If p is 2, we can keep going down this route, but we need to break this out into an algorithm, not just a bunch of if statements here. Let's see. So if p is less than k, all right, here we go. If p is less than k, there's also a 0% chance that we'll end up less than or equal to. Does she draw if she has k points? Let me check this out. Alice stops drawing when she gets k or more points. Okay, so she stops drawing at k points. So if p is less than k, she has to draw another card, which means that we'll never end up with points below k, because she'll always be drawing cards until she gets more than k points. So at this point, we also return 0.0. Otherwise, if we have more than k points, then what's our probability of getting the k points? Let's say we're at k. So if we're at points equal to k, for example, what's our probability of ending up with k points? So if we're trying to find out our probability of ending up with k points, let's see if we can break this down into a smaller problem that converges on our base cases here. So if we had k minus 1 points, we still draw, and we can end up with k points if we draw a 1. Or we can end up with k plus 1 points if we draw a 2, so on and so forth. But we're just concerned about if we pass in k here. So if we have k points that we're looking for, that's the probability of having k minus 1 points times the probability of drawing the 1 card. So that's k minus 1 plus 1 equals k. So that's going to be k minus 1 plus this per draw probability. All right, so that helps us break it down a little bit. So let's see, we'll have some internal result here. We'll call it probability. We'll start it at 0. So this probability, actually maybe we'll start it, we'll start it at 0. So this probability will now be our points will increase this probability by the probability of ending with points at 1 fewer point, so p minus 1. And then if we draw that 1 card to give us p points, well then that's going to be the probability of this per draw probability. So we'll multiply that by this per draw probability. So we had p minus 1 points, we drew that card that has a 1 point value, and we got to p points. But this also extends to p minus 2. If we had p minus 2 points and we drew the 2 card, then we have p points. And p minus 3, p minus 4, how far back do we go? Well, let's see, what's the furthest back we can go, draw a card, and end up on p points? Well, that'll be p minus max points. So if we're at p minus the max points, and we draw the card, and we get max points on that card, we'll end up at p. So we actually have to do this whole thing. We have to sum these between p minus max points and p. So we actually have to do something like for index in range. Oh, but we might go below 0 if we just go to p minus max. So we actually have to have a min index here. And that'll be equal to p minus the max points. But that's only if p is greater than max points. Otherwise, we'll just go to index 0. Okay, so now we go from our min index up to our p minus 1 points, but since range doesn't include p, we just have to go from our min index to p, and we'll add our probabilities for all of those possibilities. All right, and then at the very end, we can just return our probability. Okay, we still have a problem here. So this will go through breaking down this problem to say, okay, well, what's the probability that we ended on these earlier points and then we drew a card? The problem that we're going to run into here is we're always returning 0. So no matter how deep we go, we're going to end up returning 0 because these probabilities are all 0. So the problem with our function here is we're looking at the probability of ending with a certain number of points. What we really need to look at is the probability of ever getting a certain number of points. Because this probability, the probability of getting p points, doesn't depend on the probability of ending on the p minus 1 points. It's the probability of getting the p minus 1 points. So we actually have to change our probability function. Instead of saying the probability of ending with points, it's the probability of getting points. So we'll just say the probability of points. Okay, so we're going to change this to call this the probability of points, which means that this isn't right anymore either, because we only said we have a 0 probability of ending on points fewer than k, but we have probability of getting points fewer than k, so we actually do need to change this too. And we need to change our very first base case. Our probability of having 0 points is actually 100%. When we start the game, we're guaranteed to have 0 points. All right, so this helps us. So now that we have this, we can do a quick test. Probability of having 0 points, 100%. You start out with 0 points. Probability of 1 point. Well, if we have 1 point, well, that should be, we already know, this per draw probability, because on your very first draw, you had to draw the 1 card. So let's see if this works. So our probability starts at 0. Our min index, well, that's going to be 1 minus, we don't really know what the max points are. Let's say they're 10. Well, we already know that 1 minus our max points is probably going to be 0 or below 0. So we'll go to index 0. Now our min index is 0. We're going to go from 0 to 1, but it's 2, 1 not inclusive. So this is 0 to 0. So then we'll say the probability of ending at points p minus 1. Let's see, this should have been index minus 1. That should have been index minus 1, and it's not even index minus 1, it's just index, because we're already going through our range to p minus 1. So our probability of ending with points, and this is not ending with points anymore, it's probability of points at this index, well, that's going to be calling 0, so we'll return 1, we get a 1, and that's times our per draw probability, which is this, and that is what we expect. Okay. So this is working, I think. We can try 2. If we go through 2, we'll get the points. Let's just do that really quick. What do we expect for 2? So 2 has a couple different possibilities. We draw a 2 card on the very first round, so that's 1 over max. Now the other possibility is we draw a 1 card on the first, which is 1 over max. And then we draw a 1 card again on the second draw, which is 1 over max. So our probability of having 2 is 1 over max plus 1 over max times 1 over max. Let's see if this works out in our function here. All right, so in our function, we'll come in here, we'll have 2. Then we'll go, let's see, our min index will be 2 minus max points, so it'll probably start at 0. Our max index will be 2, or p, but we only go up to index 1. So at index 0, we're going to have 1 times our per draw probability. So this will be 1 times 1 over max in our first loop. And then we'll be adding in our second loop when we get to let's see, index 1. Now index 1 we've already determined was 1 over max. And then we'll be multiplying that by 1 over max. So that's going to be times 1 over max. And that looks like they're the same. So this is 1 times 1 over max, which is just the same as 1 over max. And it's 1 over max plus 1 over max times 1 over max. So yeah, this looks like it's going to work out. So this will tell us the probability of getting a particular number. But it doesn't tell us the probability of ending on a particular set. Okay, so for that we have to come back to our original loop here. So we're just adding up all of the probabilities from 0 to n plus 1. That's actually not what we want anymore, because this is going to be the probability of getting any of those numbers. We want to know the probability of ending on any of these numbers. So how do we handle this one? Well, we already know that we can't end on anything below k, because if you're below k points, you're going to draw a card. So we can ignore all the probabilities from the point values below k. So we can just change our range here to go from k to n plus 1. So that should give us all the probabilities of ending on the numbers between k and n plus 1. And we already know you can't end on anything below k because you have to draw cards. And we don't care about all the probabilities of ending on things above n. Okay, so this is a little bit of magical thinking, but I think this should work. Oh man, it's been a long road. Let's see if this works. Let's try it. Time limit exceeded. Okay, so let's do a quick fix here. This is just dependent on one value, which is points. So we'll just add a cache. So from functools, we'll import cache. All right, and then we'll just add that here. And we don't get the right answer. We're getting way above the right answer here. Okay, so what's going wrong? Let's see. Oh, I think what's going wrong here. Oh, this is tricky. So what's going wrong here is this min index. This min index, we're just checking to see if our points minus this maximum points is greater than 0 to find our min index here. But we don't draw any cards if we have more than k points. So this min index could actually be above k, which is a problem. So we actually need to clamp the min index to between 0 and k, because that's the only time we'll be drawing cards. Okay, so our min index is going to equal to minimum of our min index, or k minus 1, because we don't draw cards if we have k points. Okay, let's see if that fixes this. That still doesn't fix it. Oh man, I might have to go back to the drawing board on this one. Let's see, what am I missing here? Oh, I did the wrong thing. It's our max index. That's the difference. So we have a max index, and that's going to be the minimum of our points, or k minus 1. Okay, I think that's the problem. We only draw cards if we're between 0 and our max index, which would be k in this case, or the number of points we have. Let's see, but it's not inclusive, so we don't actually need this minus 1. Okay. Let's try that. Oh, and we get it. Oh man, that is super tricky. All right, just to go over that again really quick. We only draw cards when we have fewer than k points. So when we look back at all these probabilities of drawing a card, so if we had, let's say, k plus 2 points already, in our probability here, we're looking back at the k plus 2 minus 1th probability and drawing the card with 1 point on it to give us k plus 2 points. But we actually can't do that. We can't draw a card at k plus 2 minus 1, or the previous value for k plus 2. So we can only go up to k and still draw cards. So that's why we have to clamp it here. All right, let's give this a shot. We're down to 3 minutes, so let's see how we do. and we get a time limit exceeded. We passed 97 out of 151, so we're on the right track, but we are going to have to make some adjustments. So this recursive function, I don't know if there's a lot that I can do in here, but let's see if we can make this maybe an iterative function. So instead of having this function, probability of points, where we cache the values, let's just keep an array of all of our values. So instead of calling a function here, we'll just be indexing into an array to find the value, the probability for the points at that index. Let's see. Let's do it down here. So in our function here, I'll just still call it probability of points, so this will be an easy swap. We'll probably run out of time. I don't think I'll have enough time to do this in the Pomodoro, but I will keep going. So we have probability of points. We'll start that out at 0, and let's see, how many do we need? Well, we only need to go up to n plus 1 here. So we'll have 0 times n plus 1 entries. And our probability of points at index 0 will start out as 1. We'll do 1.0 just to be sure. Okay, so this probability of points will basically do the same thing that this will do, but instead of having a function, we'll just store it in an array. So now we can swap out this probability of points with some square brackets here. Okay, now we have to build up this probability of points. Okay, so let's basically go through and do the same thing we do here, but we'll do this just from 1 through n plus 1. So let's see, for points in range, we'll go from 1, because we already know points at 0, and we'll go to n plus 1. Okay, now in this case, we can just look back. So this was doing a recursive call, but instead of doing a recursive call, we can just look back in our array to find these points. So we'll need some of these same pieces. Let's grab some of this here. So we'll still grab the min index and the max index. So now instead of doing a recursive call, we're just going to use a sum of those values. So our probability here, oh, and we are out of time. That's okay. I will be back in just a second to continue this. All right, where we left off, we were turning our recursive function into an array. So we still have our min and our max index. Now, instead of grabbing the probability from a recursive call, we're just going to look back in our array to find the previously calculated value. So let's grab this probability. So this, let's see, this recursive call, we can replace this recursive call here. So instead of being a plus equals, we're just going to sum. Let's see. So the probability of points at this index times per draw probability, we're going to replace that. So our probability here, that's going to be the sum of our probabilities. Whoops. That'll be the sum of the probabilities for our min index to our max index. Let's see. Let's check our max index here, because this will be not including the max index. I think that's right. So this will be from the min index to the max index, and then we do have to multiply by the per draw probability. So this is basically the same as doing each individual one times the per draw probability. Instead, we're just going to add them all up and then multiply. It's just basically factoring out this multiplication. Okay, so that should give us our probabilities for any particular number between the range of 1 and n plus 1. Yeah, and then we can get rid of this entire function. All right, so we've done pretty much the same thing. We have our probabilities. We're starting out with points at 0 equal to 1. We still have our min and our max, but now instead of doing a recursive call, we're just going to look back in our array for the previously calculated values for those probabilities. All right, let's get rid of this whole thing. Okay, and we don't need to import this anymore. That cleans things up quite a bit. Let's see. All right, quick overview. We'll go through and calculate all of our probabilities ahead of time. So we're just going to calculate everything from 0 on up to n plus 1, and then we'll just go through and calculate our result based on the points between k and n plus 1. All right, let's see if this works. Oh, this was a silly mistake. Let's do this. That will equal 0 times n plus 1. Well, let's try that. Let's see. Looks like I need to actually do probability of points, not probability. Okay, there we go. Okay, we're looking at our probability of points between the min index and the max index, multiplying by the per draw probability, storing that in this probability, but it's not probability. We want to put, well, we can store it temporarily there, and then we'll take our probability of points at this point value, and we'll set it equal to this probability. Okay. That was my fault. Missed a couple things there. Let's try that. I'm having trouble typing. Probability. Okay, and that works. And it does pass the one test case that we failed before. So let's try this. Oh, and we still get a time limit exceeded. 106 out of 151. Okay, so we'll use this test case. All right, so, wow, this is really complicated. So the next step here is the most, I guess, computationally intensive thing that we're doing right now is this sum. And we're doing the sum over and over and over again. So the probability of these points between min index and max index, we'll calculate that sum, but then we'll just increment our min index by 1 and our max index by 1. We'll do another calculation summing up all the values in between. So we're actually doing a lot of work over and over and over again. So one thing we can do is actually try to, I guess, eliminate this sum and instead keep a running sum. So instead of calculating the sum over and over and over again, let's just keep a running sum of our current, I guess, window between the min and the max. So let's do that out here. Call it a running sum, and we'll start it equal to 0. So I'm going to grab this as our reference. So we want to replace this with just running sum. So if all goes well, we'll just have something like this. Okay, so let's see. What is our running sum? Well, our running sum will just be the sum so far, and then as we shift our min and max indexes up, we'll be dropping the last min value and adding the new max value to our running sum. So you can kind of think of it as like a window that's moving from left to right, and you're dropping the left-hand value while you're adding the right-hand value. Let's see, so our running sum, oh man, how are we going to do this? Well, let's just take this one step at a time. So what do we add to the running sum? Well, we'll be adding the max index to our running sum, or not the max index itself, but the probability of points at that max index. Okay, so we'll be adding the probability of points at this max index to our running sum. That sounds pretty straightforward. I think that's right. No, it's max index minus 1 because this was previously not inclusive of the max index. So we'll be adding the max index minus 1. But if we start at 0, well, I guess we're starting at 1, so that should be okay. Okay, so that actually might work out. We might not need to do anything else there. What about subtracting the min value? Well, let's do that one then. So we'll be subtracting as we move elements or probabilities out of our window here. We'll be subtracting something. So we'll be subtracting the probability, let's see. So we're subtracting the value at the min index minus 1 though, because the min index was included. So this will be min index minus 1. Now that min index could be 0. So this could cause a problem if it's 0. So that's only if this min index is greater than 0. Otherwise, we'll subtract 0. We won't actually subtract anything. So we'll just be adding values to our running sum up until we reach, I guess we'll always just be adding values to our running sum. Let me rephrase this. So we'll start our running sum at 0. Then as we move through our window here, we'll be adding the max value to our running sum. At some point, we'll start subtracting our min index values when we get a min index that's greater than 0. Otherwise, we'll just keep adding to our running sum. So we're just adding until we start adding and subtracting. Okay, I think that should work. Let me try it and see. Oh, and it doesn't work. So I've got, oh, and look at these values, way off. So let's see. I'm missing something here. Previously, we're doing a sum of the min to the max index. Now we're doing the sum adding these max indices, -1 because it's not inclusive. Let's see here. And then we'll be subtracting. Oh, here's the missing piece. This max index could get stuck at k, or it will get stuck at k at some point. Now, previously, we're just adding up to the max index. But in this case, we keep adding that same max index over and over and over again. So we only want to add if, let's see, what are our conditions for this if? Let's see, if our points are less than k, I think it's if they're less than k, otherwise we'll add 0. I think that's it. Let's give that a shot. Not quite. Is it less than or equal to? It is less than or equal to because we want to go up until we reach k, then we'll add that one time, and then we won't add anything after that once p exceeds k. Okay, let's try that. There we go. Oh man, this is a tricky problem. And we get a wrong answer. Let's see, we'll use this test case. Okay, let's take a look at this test case. This might tell us something. N is 12, k is 1, max points is 10. Oh, so our n is greater than k plus our max points. So this is another edge case that I didn't account for. So, all right, if we're only allowed to draw one card, so after our first draw we have between 1 and 10 points, then we can never, or we can always have something below n. We can never exceed n. All right, so this is another case. So if k is equal to 0, or n is greater than, let's see, it's going to be k plus the max points, because that's the maximum we can ever get. We only draw cards while we have below k points, so the max points we can start with and draw a card is k, and then the max points we can end up with would be k plus max points. And if our n is above that, actually I can say greater than or equal to, then we'll return 1. We have no way of exceeding our n, so any points we end up with will be less than or equal to n. All right, let's try this. All right, it passes. Let's see if we can pass all of the tests. Oh man. Oh, and we pass. Okay, we do terribly. We only get 6.96% for runtime and 30% for memory. So this is not a great algorithm, but it works, and this is a tricky problem. So one thing we could do, we could actually grab this. Looks like we're doing 2 loops of 1 through n. Well, 1 through n plus 1 and then k to n plus 1. So we could actually do some conditional inside of this loop, say if we're between k and n plus 1, just add to our result. Actually, let's do that. That should be a quick fix. So instead of doing this loop and then this loop, we can actually just roll this loop into this loop here. So let's see, we just need a conditional where if our points are greater than or equal to k, then we'll add those points to our result. And that takes us between k and n plus 1. So that might save us a little bit, but now we have another conditional in our loop, which actually might slow us down. So it's hard to say which is going to be better. Let's try this. Still works. It doesn't really save us anything. 6.96 versus 6.96, it does nothing. Yeah, stats are exactly the same. All right, well, thank you for bearing with me on this one. This is probably the hardest medium I've ever seen. So that is it for me. Hope you enjoyed this, hope you had fun, hope you learned something, hope you can do this one, because this is a tough problem.